Here we have a system of linear equations. We know they're linear because x and y are to the first power. And so when you have a system, what they're asking you is where do these things intersect? And for two lines, the intersection or number of solutions for two lines is a reference to the idea that the lines can hit once, never, or all the time. And if they hit once, that would happen if the slopes are different. That would give you one solution. If they hit never, no solution, that happens when the slopes are the same, but the y-intercepts are different. And if they have infinite solutions, that happens when the slope and the y-intercept are the same. But the only way you can understand any of this is when you get them into y equals mx plus b format. So let's do that with both of these. On the first one, if you take away 2x from both sides, you'll have 3y is negative 2x plus 7 divided by 3, negative 2 over 3x plus 7 over 3. So in mx plus b, we can see that the slope is negative 2 over 3. The y-intercept is 7 over 3. Now let's do the bottom equation. 15y is negative 10x plus 35 divided by 15 on both sides. Y is negative 2 over 3x plus 7 over 3 because 35 over 15 simplifies to 7 over 3. So what are we seeing? We're seeing that they are the same line as each other. They're two lines that have the same address. They're always hitting, which is the idea of having infinite solutions. So now let's go ahead and draw what that actual solution looks like. It's got a y-intercept at 7 over 3, which is 2 1/3. So 1, 2, 3. So the y-intercept's around here. And then it's going down 2 and over 3. So it's going down to about there. So generally speaking, both of the lines look like this when you graph them. Now, just thinking about this for a second, anywhere on this line, any location on this line means you're in the solution. So it's not a solution like we're used to seeing. It's like a fluid solution. And that's why the solution actually has an address. And the address of that solution is the equation of the lines, negative 2 over 3x plus 7 over 3, with a smaller marker, of course. And so what we're seeing on this question, when we start to look at these answer choices, is something that we haven't really seen a lot of before the digital SAT. We're going to call this the idea of putting the answer into a verbal statement. And it's really, really weird. And what it requires is understanding what this means in a y equals format and also an x equals format. So let's go ahead and solve this for x, and you'll see why in a moment. If we solve for x with a smaller marker, of course, then we can take away 3y from both sides. 2x is negative 3y plus 7, and divide by 2, negative 3 over 2y plus 7 over 2. And so we have it in terms of y, we have it in terms of x, and this is what we mean about verbal statements. So if we look at that first equation, we can read it as the y value is what you get when you multiply the x value by negative 2 over 3 and then add 7 over 3 to that. So that is our verbal statement saying that y is what you get when you do all this stuff to x. Now let's do the same statement, but for x. The x value is what you get when you multiply y by negative 3 over 2 and then add 7 over 2 to that. And that's our verbal statement for x. So we're kind of ready for however they give it to us. And the answer that matches any of these is answer choice B. It says that we have a y value right here, And the x value is what you get when you multiply y by -3/2. So the x value is what you get when you multiply y by -3/2. Check. And then you add 7/2. Check. So teaching this question to various students in the past, a lot of them will ask me, well, how come D is not right? D reads this way. D says, well, first of all, you have an X value and a Y value. D says the Y value is what you get when you multiply the X value by -3/2, not -2/3. So it kind of looks like it, but when you look in detail, it doesn't quite match up. So once again, the answer here is B.